Hello, my name is Akinyemi Akinpelu, and I'm a graduate intern from Alum Solicitors. And in this video, I'll be discussing the concept of distributed antenna system, which can be referred to as DAS, as it relates to the telecommunications business. Distributed antenna system, or DAS, is a system that makes use of several antennas, as opposed to one antenna, to improve the quality of service in the building with more reliability and consuming less power. DAS is a form of in-building solution that's employed to improve the quality of service in densely populated large structures such as malls, hotels, hospitals, stadiums, and the likes. This is due to the fact that these structures are built with several layers of concrete or metals that sometimes weaken or totally deprive network signals access into the building, thereby not allowing the occupants of the building access to quality signals. That's why maybe you are outside the building and you have strong signals. But upon entering the building, you're not able to use your phone due to poor signals, and that's why we have DAS. That is a solution to this problem. DAS takes the network signals from outside the building and sends them into the building, distributing it around the building, thereby improving the quality of service in such a building. There are two main types of DAS. We have the passive and the active DAS. I'll be discussing this, the pros and cons, as well as the basic requirements to deploy DAS in any building. Passive DAS. Passive DAS makes use of a donor antenna that is usually at the top of a building. And this donor antenna, the job of the donor antenna is to receive signals from surrounding antennas and then pass them through coax cables to an amplifier unit. This amplifier unit then boosts the signals and makes them stronger and then sends them out through these coax cables to a network of broadcast antennas around the building. Passive DAS can also be called the signal amplifier unit. Now, active DAS. Active DAS is a system that's done through the passing of network carriers cables into a building and then sent to a digital conversion unit. This digital conversion unit then converts this RF signals, that is the radio frequency, into optic signals. These optic signals are then sent through a network of fiber optic cables. These fiber optic cables then takes these signals and converts them back into RF signals, that is the radio frequency signals, then distributes them to a network of broadcast antennas around the building, thereby improving the quality of service in such a building. Now the pros and cons of passive DAS. Passive DAS pros. Passive DAS is less expensive to implement when compared to active DAS. And passive DAS provides for the coverage of all network frequencies and signals. Passive DAS also is easier to install in the building. It's not as complicated when compared to active DAS. Now the cons of passive DAS. Passive DAS has a tendency to degrade as more cables are introduced into the system. And this makes it unsuitable for extremely large buildings that necessarily need long runs of cable. Now, active DAS. The pros of active DAS. Active DAS does not lose signal strength no matter the length of the building. It is suitable for extremely large buildings, and that's why it's best for maybe stadiums, subway systems. Now, the cons of active DAS. Active DAS is extremely expensive, as I said earlier. It's expensive when compared to the other systems. But then, if you're building a stadium, an active DAS is suitable. Also, active DAS only carries one network carrier frequency at a time. For you to install more network carrier cables, it's going to cost more money, thereby increasing cost. Now, the basic requirements for the deployment of DAS into a building. For you to install DAS in the building, you will need the permission of the owner, and also a small room to operate all these devices such as the amplifier unit, the digital conversion, and other equipment that will be needed to generate telecommunications network. Now you also need constant electricity in such a building. Constant electricity is necessary to power any telecommunications device because this device emits high heat and also they need cooling. So for constant electricity helps keep the cooling systems running and also helps keep the telecommunications system running at a very good pace. Thank you so much for listening to this. I hope you enjoyed it. Please visit our website at www.alim.com and also our LinkedIn page. Thank you very much.